two formulas and being able to use those two formulas. And we're going to go through them quickly, but I need you to stop me if you are ever lost or confused. So don't let me go too fast and you're going, whoa, I don't get it, okay? So we're going to talk about the formula for distance and the formula for midpoint. You may have already learned these or seen them before in Algebra 1. And then we're also going to review Pythagorean theorem again. And you guys have done that already in bell work in here, correct? Okay, so we're going to review Pythagorean theorem one more time, applying it to what we're learning today. And that's all there is to the notes. Starts with a review of now we're in two dimensions. We're in a coordinate plane. A coordinate plane has an x-axis and a y-axis. Remind me, what is the horizontal axis? X. What is the vertical axis? Y. The coordinate plane was developed by the famous mathematician René Descartes. When he developed the coordinate plane, he used the x and y axis to divide it into 4 regions. We call those regions quadrants. Where is quadrant number 1? Okay, top left. Where's quadrant 2? This is quadrant 1, top right. Did you guys say top left? Should have been top right. Quadrant 1 starts here. Okay, where's quadrant 2? Top left, there we go. And you go counterclockwise around your coordinate plane. Okay, so top right, quadrant 1, then 2, 3, and 4. There are some questions on your homework that may ask you what quadrant would the point lie in. And so you'll need to say 1, 2, 3, or 4. Okay? When you list your ordered pairs, make sure you're putting them in parentheses and that they're in the order x, comma, y. Okay, so I'm going to talk to you about the midpoint formula before we actually look at it in the notes because it's very crazy on your paper. So when we're trying to find a midpoint today, you're going to be in 2 dimensions on a coordinate plane. They're going to give you 2 endpoints. For example, say you have a point here and a point here. And they're going to ask you to find the midpoint of that line segment. And we know that the midpoint should split the line segment into 2 congruent parts. So what we're basically going to use today is the idea of averaging. I'm going to call this point x1, y1, and this point x2, y2. If I want to find the midpoint, then all I have to do are take the coordinates of my endpoints and average them, because that would give me the middle of those 2 values. So the midpoint, wherever it's at here, would simply be my x2 and x1. And how do we average something?
You add it and then divide it by whatever.
Exactly. You add them and divide by how many there are. So my midpoint formula here would just simply be x1 plus x2, and I would divide by 2, comma, and then to find the y value of my midpoint, I would do the same thing, but I would do it with my y values. I would simply add the 2 extreme y values, y1 plus y2, and then divide it by 2. And the midpoint is a point, so it should be an ordered pair separated with a comma. To find the midpoint, you just need to be able to average your endpoints. That's all there is to it. It is simply the average. There is one thing missing here, and that's an equal sign, if you'll add that in your notes. This is your midpoint formula. And I'll go ahead and pass out these red sheets. These are your reference sheets that you want to keep all year long. You can refer back to them. We'll use them all the time. Obviously, I want you to memorize the midpoint formula. But if worst case scenario, second semester, you've forgotten the midpoint formula, you can always look back at your red reference sheet. Okay, so everybody should be getting one of these. The distance formula is on the opposite side, and again, when we get done with the notes, we'll practice singing the songs. But this is your midpoint formula. It is a point, it has commas in the middle and parentheses on the outer sides, and it gives you the coordinates of that middle point. Any questions about the midpoint as far as the formula goes? Okay, we're going to jump right into a very simple problem, and then we'll look at one that's a little bit harder. This one just simply says find the coordinates of the midpoint. The line segment they give you is PQ, and they give you the coordinate for P, and they give you the coordinate for Q. So all you have to do is plug it into your midpoint formula. Okay? Start with your formula, write your formula. We're not going to graph it yet because I want us to get used to using our formula, because sometimes your numbers are going to be really ugly. They may be things like negative 55 or positive 233. You're not going to want to graph those big giant numbers. So the easiest way to work it, if the numbers are bigger especially, is to plug it into your formula. So if I plug it in, it's going to be x1 plus x2 divided by 2, y1 plus y2 divided by 2. All right, Riley, what am I going to plug in for the x's? What's going to go in for x1 and x2 according to this problem? Exactly, negative 8 and negative 2. So we'll have negative 8. It's plus, and it's plus a negative, so usually we would just put minus 2. But don't forget that the formula is actually plus. Sometimes when I do it this way, students start thinking, oh, it's minus in the formula, but it's not. You're averaging. And that is divided by 2. All right, and then let's go with Sydney. What's going to go in for the y values? Very good. 3 plus 7, and we're going to divide by 2. All right, guys, what is negative 8 minus 2? Negative 10 divided by 2, comma. What's 3 plus 7? 10 divided by 2. Don't forget your parentheses and go ahead and simplify. What is the coordinate for our midpoint? Very good. Negative 5, comma, positive 5. Put parentheses around it. Circle your answer. So midpoint is just the average of your endpoints. Any questions about midpoint? Okay, if you want to check it graphically, you could always plot the 2 points, and then you could plot your midpoint to make sure that it does look like it is about in the middle. So here is negative 5, 5. It is splitting that line segment into 2 congruent parts. Are we good with that? Okay, now we look at a different question. Look at the next example. Tell me what is different when you read this. Okay, what do you see? What's different? Okay, it gives you the midpoint. This time they tell you M is the midpoint, but M has the following coordinates. So they're not asking you to find the midpoint. They're giving you the x coordinate of your endpoint is 2, 7, and then they're asking you for what? The y coordinate, which is the other coordinate of your endpoint. So they're asking you to find the endpoint. There's 2 ways we can work it. I'm going to show you how to do it algebraically first, because again, if your numbers are ugly, they're big, giant, decimals, fractions, you are not going to want to try to graph those and figure it out. And then we'll look at the easier way, which is graphing it. So starting with our algebra, anytime we're dealing with midpoint, we're going to start with our formula. Midpoint equals x1 plus x2 divided by 2, y1 plus y2 divided by 2. So start with your formula. What's going to go in for capital M? 6, 1, the midpoint. So this time we're going to plug the midpoint in for the capital M because we know the midpoint. It's 6, 1. Then we're going to use the other point they gave us, 2, 7, as one of our x's and one of our y's. And then we're going to try to find the other x and the other y. Bless you. So what are we going to plug in for x1 here? 2. So we'll put 2 plus, we don't know the other endpoint x, so I'm just going to leave it x. You can call it x sub 2 if you want, but there's only one x now, so I'm just going to leave it x divided by 2, comma, and then what's going to go in for one of our y's? 7. So we plug 7 plus, we don't know the other y, so we'll leave it y and divide by 2. Is this making sense so far? Okay. From here, look at what you have. This coordinate is equal to this coordinate. If they're equal, then that means the part that comes before the comma should be the same as the part that comes before the comma. Would you agree? So we can just set those equal to each other. 6 should equal 2 plus x divided by 2. And then we can do the same thing for the parts that come after the comma. 1 comes after the comma, 7 plus y over 2 comes after the comma, so those should be equal. Does that make sense? Because we're saying this coordinate equals this coordinate. So 1 equals 7 plus y divided by 2. Stop me if I've lost you. Questions anywhere? Okay, let's do the algebra and let's solve. What would I do here to solve for x? Multiply what, Caleb? Very good. Multiply both sides by 2. 2 times 6 is 12. And then the dividing and multiplying are opposites, so they cancel out. And we have 12 equals 2 plus x from here. Not divided by 2, but subtract 2. Good. And so x is equal to what? 10. Come over here. We're going to do the exact same thing to solve for y. The opposite of dividing by 2 is multiplying by 2. Dividing and multiplying cancel. 2 equals 7 plus y. And then what do we do here? Subtract 7. And what is 2 minus 7? So y equals negative 5. And so to answer our question, what are the coordinates of capital Y? Capital Y would equal 10, comma, negative 5. So the coordinates for that endpoint are at 10, negative 5. Any questions with the algebra? Okay, let's go to the graph and look at an easier way to do it if you want to graph it. So if you have graph paper, if your numbers are smaller, I don't care which way you work it on the homework or the test, as long as it fits on your graph and you can do it and you show work. So either way, graphically, take your graph paper I passed out to you. Never make your own graphs on your homework, please. Make sure you have graph paper. I'm modeling bad behavior up here by making my own graph, but grab graph paper, make sure you have it. Okay, plot your points. So they give you, we have one endpoint x at 2, 7. And then we have our midpoint at 6, 1. And so you might have a question on your homework that says, if you're trying to graph the line XY and M is at 6, 1, what quadrant does Y have to land in? And what quadrant would you say Y is going to land in? 4. Because if this is the midpoint, then obviously this much of the line segment is also going down here, right? Okay, so you might have a question like that on your homework. Using this, if we graph it, we can just use the idea that the midpoint splits our line segment into 2 congruent parts. So therefore, the slope from x to m should be the same as the slope from m to y. So we can just do the slope. Count slope down first. How far are we going to go down to get from x to m? 6. So go down 6. And then how far are we going to go to the right? 4. So then all you have to do is repeat that slope. Go down 6, right 4, plot your point. And then my graph obviously isn't as perfect as yours since I hand drew it, but where does your y land on your graph? (10, negative 5). Everybody getting 10, negative 5? Which we should, right? Because we just did it algebraically, and what did we get when we did it algebraically? 10, negative 5. So watch your directions. The biggest mistake I see when students do their homework is they see that word midpoint and they automatically just start plugging the 2 coordinates into the formula. It depends on what those coordinates are. If they're giving you the midpoint, you're going to work it one of these 2 ways. If they're asking for the midpoint, you'll do it the first way. Any questions on midpoint? Okay, we're going to move on to our second formula of the day, which is the distance formula. All right, so distance formula, for time purposes, I'm not going to go through and explain to you where this formula came from, but you can derive the formula with the Pythagorean theorem. And using the linear distance idea that we learned back in section 1-2, that to find the distance between 2 points on a number line, you just subtract the two values and then take the absolute value. So that's why in the distance formula, you've got subtraction, and we're going to connect this to Pythagorean theorem here in just a little bit. But this is your distance formula. Key thing I want to point out is that in the distance formula, you are subtracting your x's. You are not adding your x's. Be careful, because midpoint you're adding, distance you're subtracting. You're going to subtract your two x terms and then square them. You're going to subtract your two y terms and then square them. You'll add those two values together, and then you'll take the square root at the very end. Okay, so subtract your x's and square, subtract your y's and square, add those two numbers, and then take the square root. One of the most common mistakes I see students make here is that they think, well, can't I just cancel the square root and the squares? You can't do that, because when you have the square root, it's like a set of parentheses of what's underneath the square root. And remember your order of operations. The very first thing you have to do is simplify what's inside your parentheses, right? Before you can deal with exponents. So you have to do what's in your parentheses before you can take the square root. Okay, so do not just get rid of those squares. That does not work. So here's our distance formula, and we're going to apply it to some problems. Couple of reminders. If you see two capital letters with nothing above them, what does that mean? Find the measure of the line segment, and we call that the distance. So when you see two capital letters side by side, they're looking for the distance. Do not put a line above it when you give me your answer. You're going to say FG equals and give me an answer. Notice it also says to find what else? JK. So you're going to find the distance from J to K and give your answer. Okay, and I'm not just kidding. All right, so we're going to find FG, we're going to find JK, and then there's a third part to the question. So when you see this on the homework, make sure that you are showing work, giving all the answers. Find the distance, and then what else does it ask you? Are they congruent? So you're going to tell me, yes, they're congruent, no, they're congruent. You can write it like this. You could put a slash through it and write it like this. If it's no, you could just say yes and no. Okay, but make sure that you answer the question about are they congruent. Okay, we'll do FG together, and then I'm going to have you do JK on your own. So let's try FG. First, start with your formula. Again, it's the square root over all of it. In parentheses, you're going to take x2 and subtract x1, and then square it. And I will tell you, it won't matter which order that you end up subtracting, because think about it. When you square it, what's that square going to do to the number? Okay, it's going to multiply by itself, and what's it going to do to the value of that number if you are always squaring? It's going to make it positive. So if I did 5 minus 1, I would get 4. But if I do 1 minus 5, I'm going to get negative 4. And normally it would matter which way you subtract. But when you square a 4 or square a negative 4, it's going to become a positive, right? So the order's really not going to matter. But the formula is typically x2 minus x1 squared plus, and then y2 minus y1 squared. And the square root goes over all of it. So the first thing you've got to be careful about is if they give you a problem like this, did you pick out your coordinates correctly? A lot of times I see students make a mistake at the very beginning and then their whole work is wrong. So what are the coordinates for point F? Careful, so I heard 3 different answers there. Positive 1, positive 2. Remember, it's x, comma, y. So that's 1, comma 2. Sorry, my 1's really fat now. 1, comma 2. G. What are the coordinates for point G? 5, 5. Be careful, because a lot of people want to say 4, 4, but there's one point after, so 5, 5. The other thing I would warn you about is sometimes they will change the scale and they won't go by ones. Watch your book. Watch your problems. If it says 2, 4, 6, then you know they're going by 2s, and so that's going to change your coordinates, okay? So really be careful. Okay, let's plug it in. At this point, it does not matter which ordered pair you start with, but be consistent. If you start with G for your X, start with G for your Y. Okay, if you start with F for X, then start with F for Y. So what do you guys want to plug in here in the parentheses? Say it again. Careful, 5 and 5 are x and y. Okay, so we can start with 5, and then we would do minus 1. So 5 minus 1 squared plus, if we do 5 minus 1, then what do we have to do for y? 5 minus 2. Be really careful that you are doing x minus x and y minus y. This point, just simplify. What is 5 minus 1? 4, and we're going to square it, plus, what's 5 minus 2? 3, and we'll square it. Keep your square root over your work all the way to keep your answer correct. What is 4 squared? 16. What's 3 squared? 9. Add them together. What's 16 plus 9? 25. You still have it under the square root, so what is the square root of 25? 5. So on your paper, you would say FG is equal to 5. Questions? Okay, you guys go ahead and do JK, and then we'll check. But before you do, let's do the coordinates together, just to make sure. What are the points for J? Careful. X, then Y? What is it? Negative 4, comma, 0. X first, then Y. What is your coordinate for K? Negative 1, negative 3. Okay, so now find the distance from J to K, you and your partner, and then we'll check our answers. Okay, so if you don't... $34, that's a very common mistake, but you're making a mistake with your formula because of the minus in the formula and the negative with the coordinate. So watch up here. I'm going to go through it pretty fast, but stop me if I lose you. So we're trying to find the distance from J to K, which is the square root of. We're going to subtract the two x's and square them. Remember, there's a minus sign in the formula before you even plug in those negatives. So if I'm using the coordinates for J and K, that means I have a negative 4 and a negative 1 being plugged in for my x's. So I have negative 4 minus a negative 1. What happens when you have minus a negative? Becomes a positive. Then we have plus in the formula, and then we're going to do the same thing to the y's. We're going to subtract our two y values. So I went from negative 4 and subtracted the negative 1. So I'm going to go back to 0 and subtract the negative 3. That means I'm going to have 0 minus a negative 3. So once again, I've got minus a negative, which is a positive. Okay, and that's usually where the mistake is if you got square root of 34, is with the minus and the negative. Be really careful. All right, what is negative 4 plus 1? Negative 3. But you're going to square that negative. Also keep in mind, if you were to plug that in on a calculator, which you're not going to because you don't have a calculator right now, but if you did, you would have to put it in parentheses. Otherwise, if you type this into your calculator, it's going to say negative 9. Which is wrong. If you're trying to get it to square negative 3, you've got to put parentheses around it. So be really careful whenever you do get a calculator later. All right, what's 0 plus 3? 3. So when we square the negative 3, we're going to get 9. And square the 3, we get 9. And so a lot of you had square root of 18, but remember, you have to simplify your radicals. Have we talked about that at all in here yet? No. So in Algebra 1, I'm hoping, because so far all of my other classes have said yes, they learned this, you were supposed to have been taught how to simplify a square root. And there's a couple of different ways you can simplify that. Okay? So to simplify a square root, one way that most teachers teach it is just to find two numbers that multiply to give you 18. So what are two numbers that multiply to give you 18? 9 and 2 or 6 and 3. Okay, if you can come up with the largest perfect square, then it's easier if you can do it that way. So sometimes I will write on my paper, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so forth. And I'll look for the biggest perfect square that goes in here. Because if you do that, then you can say 9 times 2, and then you can just take the square root of each one. And the square root of 9 is... And then you can't simplify the square root of 2, so it's 3 square roots of 2. A lot of teachers don't teach it that way because students struggle with finding the biggest perfect square. And so they teach you the other way, which is just simply to factor until they're all prime. So I could do 3 times 6, which neither one are squares, but I can keep going. 6 is 3 times 2, and then you look for what? Doubles or pairs. And so I have a pair of 3s, and so that number comes out of my radical. And what's left goes back underneath the radical, and I still get 3 square roots of 2. But it's a little harder when the numbers get bigger in the sense of it's longer. You'll have lots of factors. So for example, quickly, if I had something like the square root of 32, what are 2 numbers that multiply to give me 32? Okay, 16 and 2, or 9 and 4 would be 36. 8 and 4. So if I did 8 and 4, look at what happens. I have to keep going for quite a while. And I always bring all my 2's down. And then you have more than one pair. And what do you do when you have more than one pair? Careful. There's no addition sign anywhere in this process. So when you bring those out, you're not adding them. What are you doing? Multiplying. It wouldn't make a difference on this one because 2 plus 2 and 2 times 2 are the same, but it would make a difference if these were different numbers. And then where does this 2 go? Okay, inside the radical. So this would be 4 square roots of 2. But look how fast it is if you look for the biggest perfect square. What's the biggest perfect square that goes into here? 16. So 16 times 2, square root of 16 is? And the square root of 2 won't simplify. And there's your answer. If you can't find the biggest perfect square, then don't do it this way. Just simplify it and you'll be fine. My rule for pre-AP geometry for the rest of the school year, so make sure you listen carefully. If the directions do not say it around and you have a square root, your answer should be in simplest radical form. That means you are always checking to see if you can simplify. But if the directions say it around in the book, you round in the book. You just go ahead, plug it in on a calculator, and round it. Okay? So we will always follow the directions in the textbook unless I were to give you some sort of special circumstance and I would have it typed out on your assignment sheet. Any questions? Okay, we didn't finish this problem. JK, we figured out, is 3 square roots of 2. So if this were a homework question, I would circle that. I would circle FG. And what have I not answered yet? We're supposed to check and see if they are congruent. So make sure you do all 3 parts. Are they congruent? No, they are not the same value, so they are not congruent. Any questions? Okay, if you look at the next example, it is the exact same thing, so we're not going to do it again. I'm trying to touch it too fast. Come on, catch up. I don't know why it goes so slow sometimes. Doesn't it know I have things to do today? Okay, so this example is just exactly the same thing again, so we're not going to do it. It's just find EF, find GH, are they congruent? So we're going to skip that, and we're going to jump right into the Pythagorean theorem, which we've already talked about, and I touched it too many times. Sorry. Maybe it'll go back in just a second. Okay, so a couple of vocabulary words to make sure that you are clear. Maybe it's going to stay now. First of all, Pythagorean theorem is only for what kinds of triangles? Right triangles. What do you call the 2 sides of the triangle that make the right angle?
The legs.
The legs. And what do you call the side across from the right angle? Hypotenuse. So in a right triangle, the 2 sides that form the right angle are the legs. That's going to be these 2. So these 2 here, A and B. And then the side that is across from the right angle is your hypotenuse. So that's going to be this side here. And what is the hypotenuse? It is the longest side always in your right triangle. Okay? Pythagorean theorem only works for right triangles. Our Pythagorean theorem we already talked about in bell work is a squared plus b squared equals c squared. And the reason this is brought up here is because they want you to see that you can also use the Pythagorean theorem instead of using the distance formula. But I am telling you, you have to be able to do it both ways, okay? We're practicing both ways. Pythagorean theorem, the reason why I wouldn't say you can always do Pythagorean theorem is because it's going to require you to graph the problem. And again, sometimes you're going to have these ugly numbers, decimals, fractions. You aren't going to want to graph them, and it's a lot harder to do it that way. So that's where your distance formula is nice, because you don't have to graph it. You can just plug it in. So what's going to happen is on your homework, you're going to have a problem like this. Use the distance formula and the Pythagorean theorem to find the distance to the nearest tenth from R to S. So that means you have to do the problem twice. Once with the Pythagorean theorem and then once with the distance formula. Should you get the same answer? Yes, you're finding the length of RS. It should be the same no matter which method you use. Will you use a calculator and round? You're going to follow the directions. What do the directions say? Okay, you will always follow the directions in the textbook. Okay, I'm going to say that again. If it doesn't say to round, then you'll leave it in simplest radical form. But if it says to round, follow your directions, because that's what I'm going to grade, okay? All right, let's work this one together. We'll start with our distance formula and practice it again, and then we're going to grab that graph paper, and I'm going to show you how to use the Pythagorean theorem. So right now, let's find RS. Remember, no line segment above it. Equals, we're going to start with our distance formula, x2 minus x1 squared plus y2 minus y1 squared. All right, I'm going to call on you, so be ready. Kelsey, what am I going to plug into the first set of parentheses here? Okay, and so what would I actually write down? Very good, because it's going to be 3 minus a negative 3, which becomes 3 plus 3. And we're going to square it, plus. All right, Andrew, what am I going to plug in for the next set? Exactly, because again, it's 2 minus a negative, which becomes 2 plus 1, and we're going to square it. Okay, simplifying that, what is 3 plus 3? And we're going to square that, plus, what's 2 plus 1? 3, and we'll square that. Again, keep your square root over your word, because your answer's not really equal if the square root's missing. What is 6 squared? 36. What's 3 squared? And then add those together, and what do we end up with? The square root of 45. Now, on the homework, you're going to take your calculator if it says to round, and you're going to type in square root of 45, and you're going to round it, okay? For our purposes, since I don't have calculators handed out to you, we're just going to go ahead here. I'll plug it in real quick with my special pink calculator. And you guys believe me, the answer is about 6.7. I'm assuming you can all type in square root of 45 on a calculator, right? Anybody not sure how to type it in? Okay. So 6.7 would be our answer. So follow your directions. What would this be if we left it in simplest radical form? Very good. 9 times 5, it's 45, right? And the square root of 9 is 3. So it would be 3 square roots of 5. Any questions? Okay, let's do Pythagorean theorem. So on the homework, if it says this, you're going to work it that way, and then you're going to work it again, but with the Pythagorean theorem. So grab your graph paper. And again, I'm going to model some bad behavior, and I'm going to create a graph, but you're going to make sure you have graph paper in your binder before you leave. So if I'm using Pythagorean theorem, I have to graph it. So go ahead on your graph paper and plot the point R, which is at 3, 2. And then plot the point S, which is at -3, -1. And then draw that line segment. And what they're asking you to do is find the length of that line segment. Find the distance, right? So the way you can do that is just simply to create a right triangle. To create a right triangle, you're just going to go vertically down from R and horizontally across from S and make yourself a right triangle. Does that make sense? And then you can count vertical and horizontal distances on the graph. So vertically, how far are we going down here? Count on your graph. How far is it from R down? 3, but we're talking distance, so it's not negative even though we're going down, okay? Just distance. What's the distance from S over to R horizontally? 6. And so now you have the two legs of your right triangle, and you can just plug those into your Pythagorean theorem and solve for your hypotenuse, RS or C. If we plug that into our Pythagorean theorem, we have a squared plus b squared equals c squared. 3 is going to go in for either A or B, and 6 is going to go in for the other one. And we're looking for the hypotenuse, so that is our RS, but we have to square it in the formula. You can leave it C if you want to call it C, but just remember that it's squared, so ultimately you're going to have to get rid of that square. What's 3 squared? 6 squared? And together that equals RS squared. What's 9 plus 36? And that's equal to RS squared. And so what do we do to get RS by itself? Square root. And so we end up with RS equals the square root of 45, which is exactly what we ended up over here. And we know that that's approximately 6.7 since we already typed it in. Questions on how to use Pythagorean theorem graphically or distance formula algebraically? Yes. Any questions? Anybody? Okay, so on the homework, if it says to do it both ways, you have to do it both ways, okay? I will be checking to see that your work shows both ways, and you should have the same answer. And that's the end of what we're going to go over in the notes. You should see that there's another problem after that, but it's a word problem. We're just going to skip it.